So far we have covered everything that was related to concurrency and how to do concurrency by the help of threading and multiprocessing things. We understood how memory management works in Python and why there is a requirement of GIL. We will keep coming back to GIL again and again because that is kind of a core concept in Python. And if you know, recently Python in its newer version have given an option even to turn off GIL in 2024. Okay, that is one thing. So in this part, that is part 2 of event loop and async IO, our main goal will be to learn asynchronous input output operations by the help of async IO framework. So it was released in Python 3.7. With the help of async IO, we can manage how we make the coroutines, how we create tasks, how we create concurrent tasks, how we make the future, and the very important thing, event loop. So async IO manages the event loop internally, but we have to understand like how event loop runs so that we can implement Redis in a more aware manner. So in this particular section, that is part 2, we will learn about event loops, coroutines, how to make async await huge case in the like what we already know in the basic Python, and the very important thing, sockets. So in this video we will make our own socket and connect to it, and we will understand how we can get the benefit of single threaded concurrent like connections like Redis 2 by the help of async IO and event loop. So I guess this will be a kind of a very important video, and you should always go back and refer the documentation. Once we are done with this part 2, we'll go with the part 3, that is like understanding the socket in more depth by understanding TCP and UDP connections. So let's get started with the async IO and coroutines. Hello and welcome. In this video, let's start with async IO. So async IO comes by default with the Python. It's a inbuilt library. We don't have to install it manually like or separately like we do with the pip install or something in the virtual environment. So async IO helps us to write the concurrent program by the help of async await. Now we know what is concurrency, so let's see how async await helps us and what are these two things and how they helps us to write the concurrent program. So first let's understand a term, that is coroutine. So coroutine are nothing but normal Python functions like we define with the def, but they have await and async. Okay, so that we define with the def, but they have async. So whenever we add async in front of any function, it becomes coroutine. So coroutine helps us to like we can use await keyword then. Okay, then we can use await keyword inside this coroutine and await to do something, and then this pause the execution for a while till this work is done. We'll see this thing in detail, but the first thing to understand is coroutine is a kind of a wrapper over normal Python function. When we use async and it makes a coroutine, we have to invoke the coroutine and we have to execute the coroutine. Okay, so to execute the coroutine, we can't just write my coroutine and this and it will be executed. Like it's not like that. That happens in the normal function. Okay, let's say if I have a function def and a foo, and if I call let's say it's returning a hello world, and if I call this, it will run. Okay, it will execute and print hello world. But in the case of coroutine, if I call the coroutine directly, it will just return me a coroutine object. It will not it will not get code. So we'll see like what is event loop, how it runs in detail, but for now, to run the coroutine we have to pass it into the event loop. Okay, and that event loop we can create and run by a simple thing, that is async IO dot run, and whatever the coroutine you want to run, we have to pass it in here. So what I understood is coroutine is nothing but a simple Python function, and to run it we need to pass it into async IO dot run. And what async IO dot run do? It makes an event loop. One important point to note here is coroutine, because it have async, so we can pause its execution. What I like meant by this is imagine, suppose we have a coroutine. So I have a coroutine, let's say CR, and I have let's say print statement here and an API call. Important to note is it will become coroutine only when I have a sync keyword here, and if I'm doing an await call, I have to do await. If I'm doing an API call, I have to add await in front of it, and then let's say some other print statement, and then I return true. Okay, so what happened is, now this is our main coroutine, this block of code. So because this have async, this is coroutine, and this have this long running operation. This is a IO call, that is long running operation. Now what happens is, because this coroutine is having this long running operation, we want our, because obviously Python runs on the one thread, so we want our thread to pick some other task when you are doing this call. And how to do that? By help of the basic async IO. What will happen is, when this await will come, what it will do is, now let's say it was executing this, print was done, now an API call was there, so it will run some other thing in the meantime, and once the call this one is done, or coroutine will, like event loop will check like, hey, is it done or not. Then if it is done, it will go to the print and return true. So you see concurrent execution will be there, and in this time the API call was happening, and event loop is the main thread that actually manages what other coroutines are there, or it can run some other coroutine or some other thing it can do. That's important. So the API call was there, so it like run some other task, and once those tasks are done, it will give back the control. Okay, so the red represent this this coroutine, and blue represent some other coroutine. So this is how coroutine helps us to do the concurrency. So this is written here, understand. When the long running operation, this API call is complete, we can wake up our post coroutine. Okay, we can wake up this coroutine again and finish executing other code in that coroutine. For example, we finish print and return, etc. While a post coroutine is waiting for the operation, it post for it to finish, we can run other code. Okay, when while a post coroutine is waiting for the operation for which it was post, we can run other code. For example, we run this code, right? This was different code. Okay, let me use blue only. So this was some other code, and this running of other code while waiting, is the one thing that gives concurrency. Okay, very very important. So the running of other code when we are waiting is the concurrency. We can also run several time consuming operation concurrently, which gives our application big performance improvement. Okay, so this is the importance of coroutine. So now we understand why we need coroutine and what is the benefit of async await. I'm telling again one important thing that is quite confusing. I guess async is clear, that we define coroutine with the help of async. But what about await? Await means there is some extra other call is happening, or there is some time consuming process happening, so give control to something else. Await as a keyword suggests that we are waiting for this to be completed. Yes, we are waiting for this to be completed by giving control to something else. It is not waiting idle. Okay, await, you should not get confused like it is awaiting for this only to come, but it is giving control to something else. It might do some other work. Okay, and we will see this in the Python code. So this I want to emphasize a lot. So let's go to the Python console once and see how we can implement it. This is my coroutine intro.py file. So I will make a function. So we know that this is a normal function. If we return hello, or so it will be a normal function, but if I add async in front of it, it becomes a coroutine. Okay, so if I say print, so it is saying, so if I say print foo, you see it's a function, and if I do something like this, a of foo and then a, now you see it's a coroutine object foo at some location. So now you can see when we executed it like it's a coroutine. Foo was an object, obviously normal function, but when we do something like this, the A is storing a coroutine now. So now let's create a coroutine, that is add one, and we will pass a number to it, and it will add one to the number. Then we define a new function add one. It's so you can see this is a coroutine, but this is a simple function. Both are doing same thing, taking number and returning an integer by adding one into it. Then we are calling this. So this is our function and this is a coroutine. Okay, we are calling the both, and you can see we are printing two things: function result and the type. So what happens if we run? You see we get function result is 2 because we are getting 2, and the type is int. So this is clear, like when we add one, when we call one, add one with 1 into it, it will return 2. So this is, I guess, clear. But coroutine is coroutine object and the type is also coroutine. So the coroutine result is not coming because coroutine don't get executed, and I told this when we saw that asyncio.run. So if I have to implement it, I have to do what? Async. So first I have to import asyncio. I'm not doing on the top of file, so you can check, like change that asyncio.run and coroutine result. So you can see now we are getting 2 if we print the result of the asyncio.run. So what's happening is we are making a main event loop that keeps track of what all coroutines are there, which is running, which is awaited, and all of these things. We'll see like event loop later, but this is how we can make a coroutine and call them or get the result. So whenever you have to get the result of a coroutine, please use asyncio.run. Okay, so one thing which coming, runtime warning, coroutine add one was never awaited. So this is normal, like when we define a coroutine, we want it to be awaited. To do that, we use await and then the name that we want to call. So we'll see this later, but now you understand coroutine thing. Okay, so now let's see one more example and how to use await when we call the coroutine. So first we will import asyncio. Once the asyncio is imported, we will make one function that is def of add one. Again we are doing same thing, we are adding one to the passed number. So whatever the number is passed, we are adding one. Then we define a main function that doesn't return anything, but it returns none. Okay, but it like awaits for the add one. Okay, so it is awaiting for add one and it is awaiting for the add 2. Okay, I mean passing 2. So this will give 1 or 2, this will give 3. This should be. So let's print out the two things, print add 1 plus 1 and 2 plus 1. Okay, so 1 plus 1 when we are calling add 1 with a 1. And now you know how to call this like any coroutine. This is also a coroutine, main function is also a coroutine, and we are passing the main function into the core like asyncio.run. So if you see async this run is execute the coroutine and return the result. This function runs the past coroutine, taking care of managing the asyncio event loop, finalizing asynchronous generator, and closing the default executor. It also closes that. Okay, this function cannot be called when another asyncio event loop is running in the same thread. So in one thread only one event loop can run. If you use asyncio.run 2 times, it will be an issue, and we'll see that error. We can pass debug equal to true also here to see like how the event loop is running in the debug mode. And when this function always create a new event loop and close it at the end. It should be used as a main entry point for asyncio program. Okay, so this is like main entry point, and we are passing the main, and this will call other things. Okay, now this is simple case, but it is how it is. Okay, if we run it, you see we got the output 2 and 3. Simple. Okay, so this is the Python code that we wrote down. We have two coroutines, one each add one and one each main. So the main coroutine calls this add one coroutine 2 times. Okay, and then it we are running the main coroutine. Main coroutine will call other 2 coroutine one by one and then print statement, and that's it. This is how the program runs. So you can see first we will run the main. So we'll run the main. Then what happens, await in the main, this line comes await add one. So we pause the main. Okay, we are pausing the main, and then we run the this. Why? I told you earlier that coroutine can pause its execution and to wait for the another like coroutine to be executed, because we had await here. So this main coroutine was paused to give the control to the add one. Okay, and now add one is in the running state, and this main went to the wait mode. Okay, so a main is in the purge state, and run add1 was running. It returned 1 plus because the number was 1 here. Okay, so it returned 1 plus 1 and the 2 came. Now 1 plus 1 is 2, correct? And once this is done, this is the finished state. So the main came from waiting state to the running state. So now we have resumed the main. Now pointer comes to like the control comes to this line. This is again calling add1. So the run will again become the wait mode for the main function. Now this will become into the run mode. So now we have paused the main, add 1 with the argument 2 is running. We return 1 plus 1, that is 2, 3, 2 plus 1, 3, and we resume the main, and we will print out the two things and end of the program. So you can see the main coroutine was getting pushed so that this can be completed. Okay, one thing to note here is we are doing all of these things sequentially, right? Where is the concurrency? Where? So we are not having concurrency right now. So what's the benefit of all of these exercises, correct? So that's the like important thing, and we'll see like how to implement concurrency in this. So that is another thing that we'll see the next. So let's get back to the code. Okay, let's see one more thing before jumping over like how to achieve concurrency. So first I have commented out everything that we wrote previously. Now what we have to do is we have to make a function that is delay. So this is a normal coroutine where we are printing like we are delaying for these many seconds, which will pass here like sleeping for 1 second. Then we use asyncio.sleep. So this asyncio.sleep is another coroutine. It's just like to kind of mimic the API call or something. Then we finish sleeping for 1 second like that and return the same delay seconds. So this delay eventually is sleeping for the 1 second and printing the statements, nothing else. So this will use just to mimic like some API call is happening. Okay, let's say if we pass delay for 5 seconds. So this is to mimic the API calls. Then what we'll do is we will import the async. I guess already done it, but we define add1 that we did previously also. We make hello world message coroutine that actually calls this delay. Okay, and it delays for like 1 second and then returns the hello world. Okay, and we define main function that calls hello world message, that calls add1 directly, and then prints the result of these two. And then what in the end we have to do asyncio.run main. This is our whole code here, and if I run it, you see what happens is main will run hello world message. Hello world message will call this sleeping for 1 second, finish sleeping for 1 second. We return 2 here. That 2 will come into the message. Now 1 plus 1 will also return 2. Okay, we are printing 1 plus 1. 1 plus 1 is actually 2, and print message. And what was in the message? Hello. What hello word like hello word message returns on the hello word, so hello word also get it printing. So what we were doing is we first were running the main here, then we called we have to post the main because we are calling hello world message. We post the main, we called hello world. Okay, and then we post this hello world also. Just assume like it's hello world message. Okay, then we resume the hello world. Why? Because hello world called the delay, await delay. It went to the delay, did all the delaying thing and then resumed to the hello world, and then it returned hello world. Okay, returned the hello world. Then main was resumed because this is done. The main was resumed, then main was again post because add1 was running. So post and add1, it returned 1 plus 1 2. Then main was again resumed, it printed out two things, and then end of the event loop. So this is quite similar to what we saw, but like had a kind of coroutine inside the coroutine to make it a little more complex. So these two things are like again what? Sequential. Okay, how to do this concurrently. To achieve the concurrency, what we have to do is we have to use tasks. Okay, so what happens here is we are calling await in a kind of blocking manner. We are calling await in a kind of blocking manner, and this is not allowing us to give control to something else when this blocking call was happening. What is blocking call? Blocking call is something that is saying to you like, I am running, please don't run anything else. But we don't want this behavior. We want like when API call is running, when asyncio.sleep is there, some other thing can be taken up by the same thread. CPU can do something else, because you are just waiting, you are just like getting blocked by something else to be returned to you. Okay, so you can do something else. If this is a person and he's waiting for somebody to come, and so that he can resume the work, so he can do some other work concurrently, okay, like we do. So if he keeps on sitting idle and waiting for the other person to bring some files, or so that he can resume his work one, so that is a blocking state. But if this person pick work 2, and when this another like when he like gets the file, so and he start work 1 again, so that is concurrency. So how to achieve the concurrency? We have to make these two tasks. So we have to define a task 2 and task 1. And how what do we mean by task 1, task 2? So whatever the functions are, we have to define task out of them without directly calling with the await. Okay, so tasks are kind of wrappers around a coroutine that schedules a coroutine to run on the event loop, okay, as soon as possible. So whenever the event loop will show an opportunity, so it will run the task. So this scheduling and execution happens in a non-blocking manner, meaning when we create a task, we execute other task instantly without like blocking the task. So whenever we create a task, we can execute other code also, and while the main task is running. So this is like different from the await keyword that was acting in a blocking manner, meaning that we pause the entire coroutine until the result of the await expression comes back. These tasks are different from these coroutines where this await keyword coroutines, where it was kind of blocked until the result was coming back. Okay, as you can see here, right? So this task allow us to do the concurrency. So how to write the code of this? And so the one important thing is tasks are the wrapper around a coroutine that schedules a coroutine to run on the event loop as soon as possible. That's important. Okay, so how we create like task? So we have asyncio dot create task, we have asyncio dot create task, and then we pass the coroutine here. Okay, so for example, we can pass our delay. We implemented delay, right? And we pass number of seconds to delay here. Now this will not run in a blocking manner. This will run in our favorite non-blocking manner. Okay, this will help us to achieve the concurrency. Okay, so let's comment these things out. We will keep the delay. I'm commenting these things out. Okay, so now let's define our main function. We are saying like sleep for 3 seconds. So sleep for 3 is a variable. We are making a task and we are calling this delay function that we defined here. Okay, so you can see create task takes a coroutine like object coro, and okay, we can pass the name also. Schedule the execution of a coroutine object in a spawn task and return the task object. So this is a task object. We define other 2 task object also, each for the 3 seconds. Okay, then what we have to do is we have to await for the tasks. Okay, so now we are awaiting for them so that they can run concurrently, because obviously they are only just delaying, and then we are already running the main. So if we do these things sequentially, if we would have done in the previous like manner, it would have taken 9 seconds. Let's see how much time it will take now. Sleeping for 3 seconds each and finish, like it have taken just little more than the 3 seconds, because they all are running in parallel. Okay, that is there. If you like pass some else like to get like some different things running in parallel, so you can see here sleeping for 3 seconds, finish sleeping for 1 2, so you can see these are running in different order. Okay, let's do 4 here to be more precise. So you see 1 was finished first, then 3 was finished, then 4, even though we run the 4 on the second way. So you can see they are running parallelly, and whenever the execution of one is ended, event loop comes back to the to pick up some other task. Okay, so let's see what we did. We had a main function that was calling the delay. Delay was defined here. Okay, and we called it 3 times, sleeping for 3 seconds and finish sleeping for 3 seconds. Then we awaited. Okay, we have to like whenever we have to execute, we have to await the task. Okay, and then we run the main. So what was happening is, see here, first we run the main. So first the control came back to came to the sleep for 3. Okay, we have paused the main. Now run delay 3 came, because here you see run delay 3 came for the task 1. Then we have to do in the delay we are having what? asyncio.sleep3, asyncio.sleep3. So we are delaying for 3. So we have posted the delay now, and when delay was like post, we came back to this task 2. Again it was having delay for 3 seconds, so we came back to the task 3, we delayed it. Okay, then we saw that this was ended, so this was finished, then this was finished, then this was finished, and the task main was restarted. So you see this approximately took 3 seconds. Okay, how it happened is, you see we had 3 tasks: task 1, task 2, task 3. Task 1 said I have to wait for the 3 seconds. All right, 3 seconds it was waiting. In the meantime task 2 started, it also said I have to wait for the 3 seconds. Okay, in the meantime task 3 started, it also have to wait for 3 seconds. Once this was in the waiting state, event loop noticed that this was finished. Okay, so this took the control here and finished it. Then event loop was, because here also it was waiting, here also it was waiting, so event loop was kind of free, so it took the control of this and it finished it, because it saw okay this was finished. So event loop checked, okay this was done, so it picked up this task and finished it. Then same with the task 3, and once all of these things are done, await are done, we came back to the main. This is otherwise it would have taken 3 plus 3 plus 3 9 seconds, but now it would have taken approximately a little more than the 3 seconds. So you just look at these two pictures and compare how the things are different when we see these two things, these two diagrams, this and this. So let's understand this with one more example, how this concurrency works with the help of create task. So we will define a function hello every second. Okay, so we are implementing a loop here. So for I in range 2, and we will like sleep asyncio.sleep, and we will print a message that I'm running some other code while I'm waiting. Okay, then we are defining the main function that will call this task, delay task. Okay, and now we are waiting for these two tasks, and we are waiting for this also, hello every second. Okay, we are not making any task for it, but we are calling it directly, and then as we do asyncio.run main. Okay, what is happening here? Okay, so first it will come here, it will enter into a loop, it will sleep for 1 second. In the meantime this is running first delay, so it is saying that I'm in the 3 second of delay, because it is having a 3 second of delay. But when the 1 second was finished and the loop was running for every two times, so it printed out this, because now when it printed out this, it was already in the sleep mode, but it like awaited for it, and because it is already coroutine, so it went next ahead, and then this was finished, these two are again finished. Okay, so these are also running into the kind of a parallel manner. Okay, so let's understand the execution flow of this. So this was our program where we had a main function, so we were running the main first from here. So main started with the hello every second. So with that, what we are doing, okay, let's understand this with the execution diagram. So we are first like running the main is running hello what second, and first delay and second delay. So as you can see, first delay is of 3 seconds, then second delay came. In the meantime this delay was completed, so it ran hello every second, then it paused because there was like for I in range 1 second, then it run hello every second time, because again it was in loop printing, then again 1 second of delay, so 1 second was running 2 times because loop was there, and printing also 2 times. These two were in the event loop already, in the event queue they were already there, but they were delayed. So this was done here. Now our program was not doing anything because both were in delay, but our event loop noticed that it is finished, 3 seconds were done, so it completed it. Then it noticed this is also done, so first delay finished, second delay finished, and the program was returned. So even though you can see our program is getting delayed by these two things, it is doing some work of getting delayed also, like we can assume like it is doing some API call, but our function is running this, our program is running these things asynchronously, and hence doing the concurrency. So now you understand, we have seen these 4 things, and you can compare how we went from a sequential flow a more like complex sequential flow than a concurrent flow. Next, what we have to see, like the problem with the task, they can keep running indefinitely. So we have to ensure that we do set timeout, we check the like errors that can be thrown, okay, these type of things to make our code resilient.